In this video, I'm going to talk about the process of data mining. The process of data mining can be thought of as several different steps. First of all is to understand the purpose of why the data mining is being done. Oftentimes, people will jump into a large data set and start doing analysis without really knowing what it is that they're looking for. And in the end, it ends up being unsuccessful and unfruitful for them. Once that's understood, obtaining the data is the next step. And in this course, it's going to be easy to obtain the data because we have, for the most part, we're going to have data sets given to us that are clean, and so we don't really have to spend too much time doing that. The third step is to clean, explore, and pre-process the data, and that combined with the second step actually turns out to be a bulk majority of the time that is spent data mining. So as data mining managers, you keep that in mind, that your data miners are going to be spending a lot of time doing these things, and not so much time actually doing the statistical analysis or model building. And once the data is obtained and pre-processed, we'll talk about partitioning it if necessary, and generally that is going to be necessary, but depending on whether you're doing supervised or unsupervised data mining, that brings us to specifying a task. Do you want to classify? Do you want to cluster? Do you want to make predictions? Once you've decided that, to choose the techniques that you're going to use. And when I say choose techniques, I mean generally you're going to pick one, you're going to use it, and you're going to, regression for example, you're going to fit several different models, and then you're going to make comparisons with that to the neural networks. And you're going to have several different neural networks, and you're going to do this step 7, iterative implementation, over and over and over again. In other words, you're going to tune the models, and then eventually you're going to come to one that come to a state where you're going to compare the different models that you've set up, and in the end you're going to evaluate which one's best and then use the best model. When it comes to obtaining the data, we're going to use a statistical technique called sampling. And we do this because typically the databases that are used for data mining are very large. In fact, they're oftentimes so large that computers can't actually incorporate all of the data and use all of the data in fitting the statistical models. The sampling is used to break the data set up into smaller parts, or sample different parts of the data set and fit the models, and then because we don't want models to be, or results or decisions to be dependent on the sample, we apply those models to other samples or other partitions. Once that's done, we can then score the various different models that we use, regression, the neural networks, CART models, and so forth, to compare and see which of those techniques is better for, or best for the overall database. Rare event oversampling is something that's actually very important and very useful in data mining. And the idea behind data mining is that as you fit your model on your training data set, and then use that model on other data sets, is that the model is learning from the data. So if you have a rare event, let's say maybe you have 100,000 observations, and 10,000 of them have this rare event, which we'll call a yes, and 90,000 have this not rare event, which we'll call no. So we've got 10,000 yeses, 90,000 no's. What will happen if you just do the regular data mining sampling is you're going to have 10% of your observations be yeses and 90% be no's, and the models are going to become very good at identifying the no's, but they might not be so good at identifying the yeses. So a trick to deal with that is to do this oversampling, where you basically double or triple or some multiple is used to increase the size of the yeses. So I might take all the yeses and just double and just make a copy of them. So now instead of 10,000, I've got 20,000, and then I would randomly sample a smaller number of the no's. So I might take 30,000 of the no's. So I have now 40% yeses and 30% no's, and I would fit my models, and it turns out that those models are still going to be able to find the relevant information that identifies the no's, but it will also be better at finding the information that identifies the yeses. Scene of data. Every data miner has the same tools available to them, whether it's neural networks, logistic regression, CART, decision trees, so forth. But what really separates the good data miners from the bad is this use of pre-processing. And again, remember, pre-processing is part of the preparatory pre-data mining step. So a lot of time can be or should be spent on this. And all this means is that sometimes the data we get is not in a form that is going to be of the most use for us. And so transforming a variable, for example, a numeric to a continuous variable to a categorical variable, is oftentimes something that's very beneficial in terms of helping us understand what it is that we're after with the data mining. So, for example, with height, if you had people's height, and the problem that you run into with regression, for example, is regression assumes that a change in height has the same effect on other variables, regardless of what the height is. So to change from 5 foot to 5'1", for example, that would be our x variable, has the same effect as a change from 6 foot to 6'1". And oftentimes that's a fair assumption to make, but a lot of times it's just not true. So the types of variables that we have are very important in determining what type of pre-processing we do. And we can go both directions. We can go from numeric to continuous, or we can go the other direction, although that's not always the best thing to do. So you have to be a little bit careful about what type of pre-processing you are going to do. In JMP, the different types of variables are denoted by these little icons. So continuous variables, you see this little purple triangle thing here. Nominal or ordinal variables are either red or green, and you can see where these things show up here inside of JMP. And if you're not familiar with this layout, then you will be soon, but this is the data set in here, and the columns are listed here, and you can see the different types of variables that go along with each of these things. A lot of the pre-processing that's done with the variables actually depends on what type of variable we have, so it's important to know the difference between numerical and categorical variables. And you'll see as we go through this course how we do these pre-processing things and where the benefit and the costs lie for doing that. For example, it might be very time-consuming to make a categorical variable out of a numeric variable, but that's oftentimes also where the benefit comes, is by putting that time in and making a transformation. Detecting outliers is a very important aspect of any sort of statistical analysis, but particularly so when it comes to data mining. And being able to identify the outliers is not always easy, and it's actually not always necessary. There are certain tasks that we do where decision trees, for example, where outliers don't really have an effect on the model. However, there are other ones, neural networks and regression, and for example, where outliers have a very strong effect, or have a potential for a very strong effect, and so being able to detect the outliers is important. However, what you do with that kind of depends on what it is that you're trying to do. And this is an example of when domain knowledge is required to determine if something really is an error, or if there's something that's truly extremely out of line with the other data. In some cases, what we call anomaly detection is done when we try to identify the outliers. For example, in mining for oil or mining for gold, big mining companies will look and look and look for the outliers, and it's the outliers that typically identify where those locations are. Another example of when outliers want to be detected would be airport security screening. For example, if someone's going to get on a plane to bomb with a bomb, that's an anomaly. Most people don't do that, and data mining techniques are used to be able to identify that. So this is the end of this video. I will see you shortly in the next video.